Thank you very much for coming today. Just the last presentation between you and lunch. It will start to be short and, if possible, entertaining. So, quick words about me. I maintain free and open source tools and data in the space of open source compliance, security, and license. In particular, something called scan code, something you may have heard of and may use also in some of your tools called package URL. And I'm also a co-founder of SPDX and contribute quite a bit to Cyclone DX, by the way. As we all know, when it comes to compliance, the F letter is really the important letter and the fun is important there. Especially when it comes to open source compliance, which is important when you consume open source, but is often an afterthought when you're actually producing open source. There's many tools, right? And that's a bit the problem there. Generally speaking, not all of them are really great. And there's a big problem beyond the tools not being great, is a problem of data. When I say not the tools are great, all the tools are great, I recently did a study to compare the output of many software composition analysis tools, be they open source and proprietary. And very naively, we said we were thinking that we would just create S-bombs using Cyclone DX and then compare the output and be done with it swiftly. Except that actually the S-bomb themselves were often not valid JSON, valid schema, and the data were really hard to compare, including package URLs, which was used as a way to identify packages there. On the data side, weirdly enough, there's a lot of, the data is often proprietary, and we hear a lot of the software vendors in the space that consider their information about open source packages, security and provenance being something which is unique to them, which is a problem. I think really data about free and open source software should be free itself in the first place. There's a bit more pernicious issues we see is that there's a lot of vendors that tend to have double speak. They claim to be open source. It's confusing because the subject matter is open source, so they say we're doing open source compliance, but their stuff is not compliant. They're trying to confuse a bit the buyer. And also a case where you have dual license. And the problem is that very often it's been very clear in looking at the outputs of commercial open source tools. And whenever you have this dual license going on, there's two speed. There's one speed for the commercial tools, which is much more advanced than the proprietary tools. So the proprietary tools is more advanced than the open source tool. And that's kind of sad, but it's important to understand that. And I think generally speaking, it's a call to action, and we should be able to, as a community, do better than proprietary vendors. As I said earlier on, really, data beyond tools is probably the most important frontier where we need to act. If you think about a proprietary vendor that says we have premium vulnerability information about open source packages that you can buy through a proprietary feed, how is this conceptually different from someone selling zero-day exploit on the darknet? I mean, they're putting a monetary value on important security data. It's conceptually exactly the same. I think we as a community should know better about our own open source tools, their vulnerabilities, and how to better remediate and leverage that data. One way to think of it is that if you want your open source project to be effectively used, we like to provide minimal documentation, and all documentations of all projects are not great. But that doesn't mean this is not important. And providing easy information about the origin and known security issues is really important. To give you an idea, one of the projects I maintain is called Vulnerable Code. It's an aggregated database of vulnerabilities, a bit like Google OSV. And actually, Google OSV reused some of the code we've built for this project at the same time. We're trying to get information from upstream projects to get vulnerability information from the horse mouth. It took us about 2 months back and forth discussing with the Nginx maintainers to try to understand what they meant in their security advisory in terms of which version is vulnerable or not. The problem here is that it's really scary that we likely were the very first to ask them, what do you mean in your security advisory? Like, Nginx is probably running most, if not all, of ingress and egress on Kubernetes cluster today. They don't have a lot of vulnerabilities, but it's important to be very clear about what they are. So I think it's really important that we help and work as open source project maintainers to provide clear information the same way we like to provide minimal README information to get started. They're probably as good and important docs. And the other thing, so I created this stuff called package URL, which happens to be used pretty much everywhere today in vulnerability database and software composition analysis tools. It's been a bit of an eye-opener when we did this study to see how different pearls would be and how different tools, be they commercial and open source, would come with different package URLs for the same package. The whole idea of package URL was to have an obvious way to identify a package without having a central authority. And we need to, in fact, probably provide a community resource and community data and community tools that enable both these vendors and open source projects to actually validate that the pearls are correct. The problem is simple. If you are not able to identify correctly a package, then you have two possibilities. First, you're going to guess when you look up in the vulnerability database, and you're going to have false positives or false negatives. The biggest threat, actually, from my point of view, is false positives, because you will end up creating fatigue in the vulnerability management operations. And when fatigue kicks in, you just ignore the vulnerabilities. You end up probably dedicating too many resources on things that are not worth it. And of course, the other threat is false negatives, is if you have the wrong identifier, you look up, there's no hit. Cool, I don't have an issue. But it's actually not true. You don't have the correct identifier. So I think there's an opportunity to collaborate on that, and just want to point to a few existing initiatives that exist in the space. But being able to ensure we work to put vulnerability and provenance information from package available in the open for everyone to consume and everyone to use a reference data, I think is probably the best way we can easily collaborate. And please reach out if you want to participate there. And if you guys have questions. That's pretty much it, no questions? That's awesome. So the problem is solved then. No questions? So it's, go ahead.
Yeah. You mentioned false positives, right? And we are a group of people here coming from the banking sector, and as you know, we are heavily steered by the authorities such as, for example, the European Central Bank.
Yes.
And false positives, while I do understand that they are prominent sometimes as scanning tools, the thing is that there's a perspective of the developers that they say, hey, I have this vulnerable piece of dependency which I don't use or I don't invoke in my code. And then you have the client's perspective, which they say and ask questions such as, how can you guarantee that this dependency, which is vulnerable, will be never used in the future? And you cannot guarantee that. Mm-hmm. And in this area, we are struggling to pick a side. You either have to go with the auditors and fulfill the compliance checks, but this in return makes the developer's life quite difficult. And then you might have that fatigue, as you mentioned, that they simply ignore the results coming out of it. So how do you deal with false positives in that regard when it comes to compliance reasons? Because both sides are correct in this case, but again, it's for us as security colleagues, it's hard to pick a side and be compliant with regulatory requirements, but also not make our developers and IT colleagues' life quite difficult.
Yeah, so there's no silver bullet in the space, but the point is that whether vulnerability apply to a certain context, it's a continuum and it's a range. And ideally, so when you think about saying, hey, this range of package version is vulnerable to this CVE, that's actually almost like a binary choice. When in practice, what we would like to know is whether this function that is known to have vulnerability is something that exists in the third-party code I'm using and is effectively reachable through the way I'm using the code. That's where we want to go. That's where proprietary vendors provide data. I think the effort to actually extract this information so you can use this to better prioritize vulnerabilities is one possible direction. So supplementing that with information that help. So really, to me, the key is being able to rank and prioritize vulnerabilities so you have a better way to decide which I need to attend to now versus the one that you know exists but maybe less interesting. You won't be able to get a full clean slate in any case, irrespective of the regulatory requirements. Otherwise, you won't be. The only way you'll be able to reach that is not writing any software at all, practically. But so things like reachability, which is not really available in any open source tool at the moment, seriously, is one area. And being able to collectively collect the fix and introducing patch for vulnerability in an open source project will be super helpful. Other things like systematically relating a vulnerability to known proof of concept and scripts for the vulnerability in question. So because whenever you have an exploit script for a vulnerability that's available and that you can automate, then the level, again, it's about being able to raise in the priority which one you need to attend to. This is the kind of thing you want to attend to now. The next thing is, because it's a spectrum, say in the US, there's a regulation called FedRAMP, which is a set of regulation for cloud providers, the federal government. It has many sides. One of the sides says, you need to fix any CVE that has a CVSS from 7 or above to actually provide services, cloud services to the federal government. You need to tend to all of these. The problem here is, well, CVSS. NVIDIA stopped essentially publishing regularly CVSS since February. You have a lot of vanity CVs that may have really weird CVSS and not practically things that should be a concern, but you end up being a concern because they've been published by the NVIDIA in this context, yeah. So being able to provide rating that are community agreed about the vulnerability severity in a certain context is another avenue. It's not magical, but putting the data in the open, sharing them, and being able to provide better ways to categorize, prioritize, including providing input to a regulated environment like the banking environment is probably the way out.
And I think we're on the same page because you use the term prioritization, which I like because the feedback that I get from the community is about suppressing the findings, and that's, I don't think it's the correct forward, because again, you might have some questions from the authorities which do make sense at the end of the day, technically speaking. Even if you have exploitability which says if you use this certain parameter, it's exploitable, and you are not using the parameter, but you can never ensure that the new joiner in the team, junior software developer, might change that and tweak that to the exploitable version. So if we just end up putting findings under the rug,
Yeah.
we lose track of them, and they might be relevant in the future.
Yeah.
So prioritization, I think, is the
Yeah.
correct
That's the only way out, because the problem is that being vulnerable is not a binary thing. And we tend to go for the easy solution. It's a good thing, but it creates a lot of false positive. False positive creates fatigue, and fatigue means people ignore the problem.
And speaking of fatigue, you mentioned SBOM, for example, and that's also another question that I have. How deep in the SBOM evaluation do you go? Because you have the first level of dependencies, and this is something that we don't figure ourselves as well. But then there are dependencies of dependencies.
It doesn't matter. So I'm going to cut you right now. It doesn't matter. What matters is the code you use, whether it's redistributed or deployed. So forget about these addictions we all have about dependency trees as being something important. It's important when you want to remediate, to know where in the dependency tree something lives. But what matters at runtime is the code you run. It doesn't matter whether it's a first level or fifth level, 20th level dependency. It doesn't even matter in some cases whether you run it. I mean, you could very much have a log4j installed and not used, but still expressed as vulnerability with log4shell. So, sorry to interrupt you there, but there's, I think, an unhealthy addiction to provide dependency graphs. They're useful. They're useful to remediate, to understand how to better mitigate issues with CVEs, but they're not that important in the grand scheme of things. What matters first is the code present? Is it used? And and it doesn't matter whether it's first level, direct level, third level dependencies, or somewhere far in the graph. It may matter in the sense that if a dependency is not something you control directly, it's going to be much harder for you to remediate that. But when it comes to SBOM, then really focus not so much on the dependencies and their depth, but whether they're effectively used or not. That would be my. And in some cases, it may be difficult or impractical to figure out actually the dependency tree. Lunchtime. Thank you for your time, guys.